Right, so let's proceed now to vectors, but slightly different form now. We're no longer looking at the column vectors, we're looking at vectors represented by some letters, right? So what we have here is a triangle, right, with 3 points A, B, C. Now, according to the diagram here, the movement from A to B is described by this vector here, R. So the letter with a hat represents a particular vector. So that's the vector R. The movement from B to C is represented by another vector, which is T. So again, a letter with a hat that represents another vector T. Right? We're also told that M is the midpoint of AC. So M is just a point that's exactly halfway between A and C. Now, this is what they want us to do. They want us to find in terms of R and or T, AC. Okay, so they want us to find AC first. So if you look at it, AC, they want us to describe the movement from A to C. From what you're seeing here, right, there's no direct way of moving from A to C, right? Because there's no vector information here. Our vector information is there, our vector information is there, right? So we have to move using the paths with vector information, right? So if we're going to move from A to C, we can't move directly. We'll have to move from A to B, then from B to C, right? So A to C is equal to A to B plus B to C, right? And my A to B is R, the vector R, plus my B to C is the vector T. So that's it. That's how you describe your A to C. Your A to C is simply R plus T. We've given it the answer in terms of R and T. Then they are looking for CA. So CA means you're starting from C and you're moving backwards to A. Again, there's no direct path because there's no vectors that describe movement between these 2 points. You have to go from C to B, then from B to A. So that's C to B, then B to A. Now, as I move from C to B, right, I oppose this arrow. This arrow describes movement this way, right? If I move in a direction which is opposite that of the arrow, I have to put a negative sign, right? So that's going to be minus t. So that's going to be a minus t. And then when I move from B to A, again, I'm doing the same thing. I'm opposing this arrow, right? As I oppose this arrow, I now need to introduce a minus. So that's a minus R, right? So as you can see, C to A is minus T minus R. Now, the last thing is A to M. A to M, sorry. A to M. We know that M is halfway between A and C. So A to M is half the distance of A to C. So we can write that. A to M is half the distance of A to C. But we did find A to C, right? We did find A to C. A to C is R plus T. So instead of A to C, I put R plus T. So it's half of R plus T. The half multiplies both. Half times R gives you half R. And then the half times T gives you half T. So your A to M is going to be half R plus half T. So that's how you do it there. Okay. Now, we've got something that is worth noting here. We've got a straight line, which is AB, right? So if you're told the vector AB is 4 times the vector AX, right? This means AX will be a quarter of AB. If AB is 4 times AX, it means AX is a quarter of AB, right? If it had been something like this, maybe PQ is 3 times PR, you would know that PR is 1/3 PQ, right? If PQ is 3 times PR, PR must be 1/3 of PQ. If AB is 4 times AX, AX must be 1/4 AB, right? So that's important to note, right? You may need to use that in some questions that you encounter. So just take note of that.